Students, in previous class we discussed atomic number, mass number, isotopes and isobars. In this section we will discuss about electromagnetic waves. Experiments like Rutherford's model between radiation and matter have developed understand properties of matter. Several experiments and observations helped Bohr develop a model of the atom. These experiments involve electromagnetic waves and spectra. Model of atom was a result of several experiments carried out during 20th and late 19th century. Maxwell in 1865 pointed out that a change in either electric or magnetic field with time produces other field. From this, he concluded that variations of electric and magnetic field vectors perpendicular to each other leads to the production of electromagnetic disturbances in space. These disturbances show properties of waves and can travel in space without any material medium. These waves are called electromagnetic waves. Movement of charged particle under acceleration generates waves in form of alternating electric and magnetic fields, and these waves are called electromagnetic waves. Light is a radiation. People wondered whether it was particle or wave. James Maxwell developed electromagnetic wave theory of light. Electric and magnetic fields are always perpendicular to the direction in which the wave is traveling. Thus, the wave is a transverse wave. The electric field is always perpendicular to magnetic field. The cross product of electric and magnetic field always gives the direction in which the wave travels. Electromagnetic spectrum consists of radiation in different wavelength and frequencies. Wavelength is the distance between center of two adjacent crests. Frequency is the number of waves passing through a point in 1 second, and it is denoted by nu. Its unit is second inverse and hertz, and it is related to velocity and wavelength, that is denoted by lambda, where c is the velocity of light, c by lambda, where c is the velocity of light taken as 3 into 10 to the power 8 meter second inverse or meter per second. Amplitude is the height of crest. Wave number is the reciprocal of wavelength, and it is defined as number of waves in 1 centimeter or 1 meter in length. And it is denoted by nu bar. An electromagnetic wave, like any periodic wave, has a frequency and wavelength that are related to the speed of the wave. Electromagnetic waves exist with wide range of frequencies, from values less than 10 to the power 4 Hz to greater than 10 to the power 24 Hz. An arrangement of radiations of all kinds, electric and magnetic, in order of decreasing frequencies or increasing wavelength is called electromagnetic spectrum. Different regions of the spectrum are identified by different names. We find radio waves are produced by accelerated motion of charged particles in conducting wires. Its frequency is in the range of 500 kHz to 1000 MHz, are known as radio waves. and it lies, or its frequency is 10 to the power 6 Hz. Radio waves are used in communication system. The shortest wavelength radio waves are called microwaves because even though their wavelengths are much longer than those of visible light, microwave ovens are an interesting domestic application of microwaves. Microwaves are used in radar system for aircraft navigation. Electromagnetic waves having frequency range 3 into 10 to the power 11 to 4 into 10 to the power 14 Hz are known as infrared waves. These are emitted by all hot bodies and cannot be seen by naked eyes. Infrared rays are used for heating purpose. Infrared detectors are used in Earth satellites. Electromagnetic waves that are visible to human eyes are known as visible rays. They have a wavelength ranging from 400 to 700 nanometer and frequency range of 4 into 10 to power 14 Hz to 10 into 10 to power 14 Hz. Visible rays are applied in movie screen, in cinema hall and in lasers. Ultraviolet rays are produced by special lamps and also by very hot bodies such as the sun. It lies in the range of wavelength 0.6 to 400 nanometer and frequency range is 8 into 10 to power 14 Hz to 5 into 10 to power 16 Hz. Ultraviolet rays are used to kill germs in water purifiers and it is used in LASIK, LASIK eye surgery. Electromagnetic waves or X-rays can be produced by bombarding a metal target by high energy electrons. X-rays having wavelength in the range of 10 to the power minus 4 nanometer to 10 nanometer. These rays are used for detection of fractures in bones and also used for investigation of crystals structure. The electromagnetic waves which have wavelength in the range 10 to the power minus 4 meter to 10 to the power minus 10 meter and frequency range of 3 into 10 to power 18 Hz to 5 into 10 to power 22 Hz are known as gamma rays. These are produced during nuclear reaction. These rays are used in cancer therapy and to study the structure of atomic nucleus. A wave is spread out in space. Two or more waves can exist in the same region or space. When two waves are present together, their resultant wave can be larger or smaller than individual waves. In simple words, wave is delocalized and two waves may interfere. Their interference may be constructive or destructive. In detail, you will study in physics. Electromagnetic wave theory was successful in explaining properties of light as interference and diffraction, but could not explain the phenomena of black body radiation, photoelectric effect, and line spectrum of an atom with reference to hydrogen. Light behaves as particle on Monday, as wave on Tuesday, particle on Wednesday, and we don't talk of light on Sunday. What does it mean? It means confusion. Scientists, the particle nature of light posed a dilemma for scientists. They did lots of experiments. Many experiments were carried out which could not be explained by wave nature of light. The first concrete explanation for the phenomenon of the black body radiation was given by Max Planck in 1900. Students, Why does leaf appear green? Why some object appears black? What is the chemistry behind this? What is the mechanism? What is the physics? Let us try to understand. A green leaf absorbs almost all wavelengths except the green wavelength range between 500 nanometer to 550 nanometer. That's why it appears green. Black body radiation refers to the spectrum of light emitted by any heating object. When solids heated, they emit radiation varying over a wide range of wavelengths. For example, when we heat solid, color changes continue with a further increase in temperature. This change in color happens from a lower frequency to a higher frequency as the temperature increases. In many cases, it changes from red to blue. The red color belongs to the lower frequency region of the electromagnetic, while blue color belongs to higher frequency region of the electromagnetic spectrum. Students, you can observe black body radiation in the filament of light bulb and heating element of the tester. An ideal body or perfect body which can emit and absorb radiation of all frequencies is called black body. The radiation emitted by such bodies is called black body radiation. We can say that variations of frequencies for a black body radiation depends on the temperature at a given temperature. The intensity of radiation is found to increase with an increase in the wavelength of radiation, which increases to a maximum value and then decreases with the increase in wavelength. This shape of the intensity versus wavelength at different temperatures could not be explained by wave theory of light. First attempts were made by Rayleigh engines to model the curve. The Rayleigh-Engines law agrees with experimental results at larger wavelength but strongly disagrees at short wavelength. Its resolution in 1900 with the derivation of Max Planck's law, which gives the correct radiation at all frequencies. Different atoms and molecules can emit or absorb energy in discrete quantities only. The smallest amount of energy that can be emitted or absorbed in the form of small packets. Each packet is called quantum. In the case of light, quantum is called photon. Energy is emitted in fixed multiples of some energy, and the emitted energy is proportional to the frequency of the radiation. E is equal to, here is given the equation. E is equal to h nu, where h is Planck's constant and nu is the frequency. Planck could explain the black body radiation using quantum theory of electromagnetic waves. In 1887, Heinrich Hertz performed a very interesting experiment in which electrons were ejected when certain metals like potassium, rubidium, and cesium were exposed to a beam of light. The electrons travel in the tube and current was recorded. Thus, this effect is called photoelectric effect. On the basis of experiment, he observed that the electrons are ejected when some metals were bombarded with light, Light causes electrons to emit from metals.